Exactly.
That makes sense because we should see an arc that goes up and then down if we're talking about football.
Yep, exactly right. Exactly right. You guys already have like an intuitive sense about what these shapes are going to look like because we know what parabolas are, and you already have an idea about what something looks like when you throw it up in the air. It's going to come back down, right? So let's take a look at some of these problems here. So number one, we're talking about a punter, okay, that kicked a football into the air with an upward velocity of 62 feet per second, okay? Its height, the football's height, right, in feet after t seconds is given by the function h of t equals negative 16t squared plus 62t plus 2, okay? You can see, do you need a spare one?
Yeah, do you want?
I do have a spare one. It's over there in the corner, okay? This initial velocity here, wow, I didn't realize I had 4 people out there. Okay, that was weird. Okay, so anyway.
That was my thought.
No, it's probably both of us too. The 62 feet per second is right there. You can see it happening, okay? This negative 16, okay, that's the gravity. That's gravity being represented right here, okay? Negative 16, that's because it's like it's affecting, negatively the height of that ball, the ball, okay? So, we're asked a few questions here. Letter A, how long will it take the football to reach its maximum height? Okay. Letter B, kind of got cut off there. Letter B, what is the maximum height the football reaches? And then letter C, when will it hit the ground? And you can see here there's a little space for us to graph. Okay. Now, our axes are not labeled here. All right. So Brady and Dawson, let's take a look here and think about how we're going to label these axes. Okay. The x-axis here, right, in our formula, which variable is acting like x? T. And what does the t represent in this problem? Stands for time. Time with what units? Time in seconds. Okay? Oops, sorry, it's off the screen. There we go. Okay? And then the y-axis also is not labeled. What variable here, or what thing here is representing the y? The h of t, the height, right? So we're going to put height here on the y-axis. And what label will we give the height? What units?
What are you going to measure it?
It's, yep, I hear feet. That's right, feet. Okay? So, now, how are we going to graph this thing? Well, what's one option that we have to graph it? Graphing calculator, that's right. Okay, so let's type this thing into our graphing calculators here. All right, and this is going to be helpful for all of you to type it in. So I really encourage you, get those calculators out, type it in. Okay, because something weird's going to happen here, and if you don't follow along and you don't learn how to, change some settings, you're going to be stuck. Okay, so let me just show you. You all know what to do to type it in, right? Press y equals, we'll do negative 16. Now, the function has t's, but I can't really use t's here. I mean, you might see a t written right there, but if you press that button, it's going to be an x. Okay, so we're just going to use x's, but it's just like t's, Okay.
How do you get to t?
Good question. We'll talk about that another time, but I will show you how to do that if you want to. Okay, you have to change the mode of your calculator, one of the modes. Okay, it's parametric mode. But if you really want to know DOS, I'll be happy to show you another time. Okay. So there it is. We're going to graph it now. Okay, and we run into the same problem, right, that I think, Grayson, we were talking about before when you get it typed in here, okay? What's the issue with this graph? We can't see the top. We can't see, like, all the behavior. Is that what you're going to say, Olivia? Yeah, we can't see everything, okay? So, but let's take a look here. Where do we think the top of this parabola lies? Is it above? Is it below? Is it to the left or to the right? Where do you think that top lies?
Way above.
It's way above, right, okay? So how can we adjust our viewing window here? We're going to press the window button, okay? And you can see we have lots of different numbers we can play around with here. We could change our x minimum. That would make us go further which direction? To the left, right? If we change our x maximum, that would make us go further to the right. But of course, we want to go up. So which one of these should we change to go up? Y max. Okay, now, what number should we put in for y max? Sure, right? Here's the thing. Like Alex said 70, I have no idea. This is where you guys are going to have to kind of guess and check a little bit. We know we want to go up more. Some of you might have thought, let's try 20. Sure, you can try 20 if you want to, or some maybe 50 or 100. So let's try 70 because that's what Alex said there. Okay, let's see how it looks. Okay? Was 70 a pretty good estimate there? Yeah, because now we can see the top. If you want to go even higher, you can. We can go to like 80 or 100. Okay?
Alex, what made you guess 70?
Okay. Well, there you go. Well, you can see 100 works pretty fine too. Okay? You wouldn't want to do something too crazy like 1,000, right? 1,000 for your Y max. It's going to be, I mean, you can still see it, but it's it doesn't have the right feel for it. Let's go back and just make it the 70 that Alex said. That'll be fine. Okay? So, let's think about now that we have our window adjusted, let's think about how we're going to graph this. Let's look at our x-axis here. Okay? Where should we start on our x-axis with the numbers? What numbers should we start with on our x-axis, you think?
Think about time.
X-axis.
Yes, thank you.
Yeah. Should we include negative numbers on our x-axis here?
No.
Why not? Jack?
Because the person who's throwing the football is not starting.
Yeah, they're going to start at time 0, right, is when the ball goes up in the air, right? We're not going to go back in time, right? We don't have like a flux capacitor or a DeLorean or anything like that. So we'll just do time 0. Okay? Yeah, right. So how far out do we need to go here? Well, if you look at the graph, how far, where does our ball kind of stop? 4 seconds, let's count. 1, 2, 3. I think 4 is realistic. And if you wanted to go out like maybe 1 or 2 more seconds, that's fine. So let's say that. So 1, 2, 3, 4. I'm going to go out to 5 just because, just to have it like a little extra. If you want to go out to 6, that's fine too. Okay? Now, what about the y-axis?
0.
Okay, yeah, so 0 for the lowest point. That makes sense. Okay.
10, 20.
You want to count by tens? That's probably a good idea here because remember, what was the y max that we put in? 70. And so that gets us a pretty good shot here. So let's just go ahead and count by 10. So 10, and we'll say 20, and then 30, 40, 50, 60, and then there's 70. Okay? Looks good to me. Alrighty. Now, how can we get some points to actually plot here? What have we done in the past? Jackson? Okay, we can look at the zeros. That's right. Okay, how do you find the zeros? What do you do? Okay, so you're just going to look there.
Whatever intercepts the x would be at no time in 4 seconds.
Okay, and we can actually use our calculator to find the exact zeros if we want to by pressing second trace and using the 0 command too. Okay, if you just go, again, you'll see left, go to the left of your 0, hit enter, and then go to the right of your 0, hit enter, and then go like, oh, well, actually, you can see it actually gives you the point there when I do the trace. So if I hit enter, it gives me 0. Oh. Okay, yes. Okay, so we actually get a negative x value here. Now, that's interesting. Maybe we should go to our table. Let's go to our table and see what's going on here. Second graph. Okay? Let's go to our table and do second graph because that 0 was kind of weird. Right? When I did the 0 command here to the left and to the right, I got a 0 of a negative number. Do we want to include a negative number on our graph here?
No.
Not a negative x value, and definitely not a negative y value either. So, like I said, let's go to our table here and see. And then, yeah, John's right. At 0, we're starting at 2. Now, is that weird? Is that weird that our graph at time 0, the ball is already in the air 2 feet?
No, you're standing on it.
What's that?
It's in your hand.
It's in your hand, right? When someone punts the ball, right? Aren't they holding the ball and then they release it and kick it? So the ball is already in the air when it's kicked, right? For a punt, right? And so that's why we're already 2 feet off the ground. The ball starts 2 feet in the air, then it's kicked, and it's going to go up, right? So then we'll get the next point here, 1, 48. So 48 goes to like right here. And then 262. So there's 2. I'm just going to go a little bit more. And I'm just eyeballing these right now. 3 is 44. So something like that. And then 4, we get negative 6. Okay, so negative 6, I don't want to graph that one either. Okay. So that gave us some points. But what's the most important point of this graph? The vertex. How do we find the vertex? What command are we going to use here to find the vertex? It's the what of the graph? The highest point, or the maximum. So we're going to press second trace and go to maximum here, because we really need that vertex too. The table helps us get some points, but the table doesn't always have the vertex in it. So we're going to go to the left and hit enter, go to the right and hit enter, and then by up towards the top there and hit enter. Okay, and we're going to approximate this. So at about 1.9, we're at about 62. In fact, I'm going to write that out. Okay, the vertex, I'm going to write that out for us. I'm going to round here to the nearest hundredth, it says. Okay, so you can see here, oh, sorry, I wrote it out, and it's a good idea to write out that vertex for yourself because we're going to be needing that. Okay, so 1.94 and about 62, so something like right here, we'll say. Okay, so our graph is going to look something like this. Okay, like that. Huh, maybe I should have done it, well, more like this, I guess. Anyway. Okay. Not perfect, but pretty good there. Okay? So again, how do we graph this? Well, first we put in our graphing calculator. We looked at our x-axis to see what we should count by, and it was just by ones. Our y-axis counted by tens, right? We found the vertex, and we used our table to get some more points. Okay, found the vertex, and we used our table to get some more points. And now we're ready to answer some questions. Okay? So, letter A asks, how long will it take the football to reach the maximum height? So long means our answer should be in terms of what units? Jackson? Time. Okay? So what is the time when the football reaches its maximum height?
What do we say up there? What's that point? It's our vertex, or our axis of symmetry.
Mm-hmm. What's the time, right? Isn't this where the football reaches its maximum height? Right here. That's the highest point. Okay? And this is height, right? So the highest height is right here. What time is it at that point? So yeah, and in fact, remember, I found the vertex here using the maximum command, and it's exactly like, well, I rounded it, 1.94 seconds, okay? So at 1.94 seconds, okay? The highest point, that's why I had us write down the coordinates there, because we're going to use those numbers. Okay? Letter B, what is the maximum height? Letter B, what is the maximum height that the football reaches? Go ahead, Olivia. I thought you were going to say, sorry. Well, so you can see this is the height of the football over time, right? So the highest point's right here, and that's the vertex. So what does the vertex say is the highest height that we're going to reach? You got it, Sky. Go ahead, though, Olivia. It's the 62. And yeah, 62.06. Yeah, my handwriting, right? But it's, yeah, 62.06. What would be our units here?
What are we talking about? Inches? Miles?
Feet. Yeah, see? Height in feet. Okay. Ooh, here's a good question. When will it hit the ground? Where are we going to look on our graph here to determine when it hits the ground? Sky? The x-intercept, okay? Right. Do we want to find the x-intercept over here? No, because that's like earlier in time, right? We want to find the x-intercept over here is where it's going to hit the ground. So we can go back to our graphing calculator, and I want to find this coordinate. So I'm going to press second trace, and again, it's the 0 command, okay? Make sure you're to the left of your 0, so I'm following my little cursor. Okay, to the left of the 0, hit enter. I'm going to arrow over and be the right, hit enter. I'm going to go in towards it and hit enter. Okay, so what's the time when it hits the ground? What's the graphing calculator tell me? What's the time when the ball hits the ground? About what? about 3.91 seconds, right? 3.91 seconds right there. This is, again, a rounding error. You can see it's on the x-axis right here, right? That should be 0. But again, this is a calculator, a little rounding error. So 3.91. Really? Did you use trace or did you use the 0 command? Okay, use the 0 command and you'll get that answer as I got. Okay? So after 3.91 seconds. Okay? Please make sure you're including labels here, folks. Labels are a part of it, right? It says in the directions even. Be sure all answers are rounded to the nearest hundredth and include labels. All right, bring it up here, Grace, and I'll take a look at them. Okay? All right. So, questions on that? We're going to try another one here. All right. Yeah, but let me take a look at this first. Okay, so you used, I think, the maximum command or something. I'm not sure what you did. So second trace, 0. Okay, you want to go over here and then hit enter when you're to the left of your 0. Then move it over so you're to the right of your 0, hit enter. And then for the guess, hit enter one more time. There it is, 3.91. Okay. All right, next one. Let's take a look here. A disk is thrown into the air with an upward velocity of 20 feet per second. Okay, so maybe like anyone ever throw a discus before or something like that? You know, something like that. Used to. Okay, back in the day. Yeah, me too. Wasn't very good, but that's okay. Anyway, maybe a disc, maybe it's a frisbee or something like that. Who knows? All right, but a disc is thrown into the air with an upward velocity of 20 feet per second. Its height in feet after t seconds is given by the function h of t equals this. Okay, so again, we're going to graph it. So let's go to our graphing calculators here. Okay, let's type it in. Shh. Brady, type it in. Okay, type it in the function here. Okay, just like that. We're going to graph it. Okay, now if you look here, it's a new scenario, new situation, and so our window looks a little bit funky now. We can send it back to the normal viewing window. So you can reset the viewing window back to like the default if you press zoom and then go down to number 6 for Z standard. That'll set it back to the normal viewing window. But that's still not that great. Okay. So again, if you want to set it back to the normal viewing window, you can go down to zoom standard, and that sets it to the normal viewing window. But it's not that great because we need to adjust our window. Which direction do we need to adjust our window here? Olivia, you have a question? Did you put negative in front of the 16? It should be negative 16 t squared. So, okay, so we're going to adjust it up, right? So let's go to our window here. My y max is currently 10. What do you want me to adjust it to be? 30? Okay, let's try 30. See what happens. Okay, 30 looks pretty good. Okay. I can also adjust my x max. It looks like I'm going too far to the right here, don't you think? Like we don't need to go all the way out to 10. How far out do you think we need to go on the x-axis? Let's try 5. So I'm going to change my x max to 5. I'm going to reduce it. Okay, that's a little bit better. I can also adjust my x minimum too. I don't need to go all the way to the left here. I can change my x minimum to be like -2, for example. Okay, and there's maybe a better shape right there. Okay, you can get a little better view of it. Okay, so what did I do? There's my windows again, if you're interested. I moved my x min in some because we didn't need to be that far to the left. I also moved my x max in some because we didn't need to be that far to the right either. Okay, and we get a graph that looks like this. Okay, so let's go to then sketch this on our graph right here, our grid. Okay, what is the x-axis label going to be? What's the label for this? Time in seconds. Okay, and what's the y-axis label going to be? Height in feet. Very good. Okay. On the x-axis, where should we start on the x-axis? Numbering. Start with what number? 0. I think so. Okay. And how far out do we need to count on the x-axis? How many numbers do we have to count out to? I'd say at least 2, right? You can see 1, 2. Let's go ahead and just do 3 though, just because. So 1, 2, 3. I'm gonna spread it out. Okay, I kind of didn't leave myself enough space there. I had to squeeze it 3 in by the seconds. Okay, so far so good. I don't leave anybody behind. Anyone need some more time? Anyone falling behind here at all? No? Okay, we're good. All right, what about our height? Well, let's go ahead. I'm going to do it a little bit differently here. Let's find our maximum height here. So second trace. Let's go down to maximum. Okay, I'm going to go to the left, hit enter, go to the right, hit enter, and then go up towards the top and hit enter. Okay. According to my graph, what is the highest y value that we really need to have? 12.25. So maybe 13 if we want to round it up kind of thing. So that's the highest we have to go. Okay? So we have some choices here. On our y-axis, we're going to start at 0 again, right? But what do you want to count by here on our y-axis? Do we want to count by 1s? Maybe 2s. I like 2s maybe. That's probably a good idea. Let's count by 2s. Okay? 2, 4, 6, 8, 10, 12, 14. Yeah, that'll just fit for me. Okay? That'll just fit for me there. Yeah. Okay? And I'm going to go ahead and plot this vertex as well because, well, why not? So 0.6 is like right, well, there's 0.5. So I'm going to say 0.6 is about here, and then 12.25. So there's 12 and a little bit more. There we'll say is 12.25. Okay, and again, I'm going to label this point because that's an important point to know. Okay, I'm going to label it just because it's important to know that point. And I'll go to my table to find some other values here. So at 0, I get 6. Okay, at 1, I'm at 10. Okay, and then at 2, I'm already negative. So I only get 3 points there. Well, I'll just go ahead and graph it. I do want to try and figure out the 0 here. Let's go ahead and figure out the 0 too. So to figure out the 0, I'm going to press second trace and use the 0 command. Okay, hit enter to the left of your 0, hit enter to the right of your 0, and then on the 0, hit guess. Aha, 1.5. That's actually not too bad to graph. I'll put it right there. And so then we got our 0 right there. Okay. Alrighty. So there's our graph. Okay. And again, it's all in that first quadrant. Negative time doesn't make any sense. So no negative x-axis. Negative y-axis doesn't make any sense because we don't want to talk about like the disk going underground or anything like that, right? Okay. Yeah, it could be. That's true. You could tombstone it or something like that. All right. So now we have it all graphed. All right. Ooh. So Frank, how long will it take the disk to reach the maximum height here? 0.62 seconds. Very good. The x-coordinate of the vertex there. Okay. Thank you, Frank. Eric, what is the maximum height of the disk? I'll let you finish writing there. Okay. So Eric, what's the maximum height of the disk?
12.25.
Yes, very good. 12.25. What would our units be?
What are we measuring?
Feet. 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 Okay, feet. Very good. Okay. And then Cameron, what time is it going to hit the ground again? 1.5. Very good. And that's not an estimate. That is exactly what it was. Remember, we found that point. So 1.5 seconds. Very good. Okay, that's when it hits the ground. Awesome. Okay. 0.63. Check your rounding there. to the hundredths place. All right, flip it over here. We do one more.
No, I mean like how far.
Hang on, I'm looking here, Grayson. I get 0.63, Grayson. Here, let me show you. Are you using trace again, or are you using second trace with the maximum command? Okay. Okay, that's... Did you type it in correctly? Check your y equals. See if you typed it in correctly. All right, one more here, folks. Okay, go ahead. Let's type this one in, folks. Let's type it in. Type it into your calculators here. Okay, let's type it in. Graph it. So, when I graph this new one here, do I need to change my x-axis at all? What do you think? Do I have to change my x? Should I change my x-axis at all here? No. That looks pretty good, doesn't it? So I won't. Okay, but what do I need to change here? The y, yeah, and specifically the y what? The y max, right? The top of the y. So I'm at 30. What do you want to say I should go up to here? 60? All right, we want to double it. Okay. There you go. 60. That looks pretty good. The window? Yep. You want to see what I've got? Okay, yeah. There's my settings that I have right there. And again, you guys can feel free to play around with this. Of course, I've played around with it for many years, so I can, get a pretty good feel for it pretty quickly. But you guys can get pretty good at it too, so you can move things around. Okay, it's really helpful to be able to adjust your window. Okay.
What is
X. What do you think it means? SCL stands for scale. So it's like what our tick marks are counting by every time. Now, of course, sometimes you have so many tick marks, it's just one big black block here. But here, for example, you can see it's counted by ones. So, yep, it's for scale. Okay, so x-axis, again, what should we label it as? What's like our x in this situation? It's t, and the t is representing time in seconds. So again, it's just time in seconds. I think I put too many humps in my m there. There we go. Okay? And again, it looks like I'm going 1, 2, 3, 4. So I just go out to 4. So 1, 2, 3, and 4. Okay? Y-axis, also, it's height again. So it is height in feet. We're talking about a golf ball here, right? Golf ball is chipped into the air. What do you want to count by here on the y-axis? Tens again? Okay. 10, 20. Okay, if you did fives, that's okay. Yours is going to look, might be a little more stretched out than mine is. Okay. 10, 20, 30, 40, 50, 60. I'm going to go ahead and find that vertex. I'm going to go ahead and find the vertex. So second trace, maximum. Go to the left, hit enter. Go to the right, hit enter. Go in towards it, hit enter. Okay, not super nice numbers. 1.56 and 41.06. So 1.5 is here, so a little bit more. And then 41, a little bit right there. And again, label it. Whoops. Come on, Mr. Wid. 1.56, 41.06. There we go. Okay. I messed up so much I had to move my little line there. And then I'll go to my table, maybe get some more points here. So let's see what I got. Okay, it's 0. I've got 2. It's kind of interesting that your ball is already be 2 feet in the air when you're chipping it, but all right.
I think it's because of the tee.
Oh, yeah, but still, that's a pretty high tee if you think about it, 2 feet in the air. Yeah, so I don't know. Anyway, we'll just take their word for it. Yeah. Okay, 136 238, so something like here. And then 38, so something like right there. Okay, and then the 0, I guess I better figure out what the 0 is. So I'll go to back to my graph, second trace, 0. Go to the left of the 0, hit enter. Go to the right of the 0, hit enter. And then guess about 3.1 or 3.2. So we'll say, like, I don't know, like right here, we'll say. I'm going to label that 0.2. 3.16, comma 0. All right, connect the dots. Okay, just like so. All right, let's answer these questions here. How long will it take the golf ball to reach its maximum height? 1.56 seconds. Good. Okay. What is the maximum height the golf ball reaches? 41.06 feet. When will it hit the ground? 3.16 seconds. All right, your homework, folks, is to finish number 4. So do number 4. I know. Number 4. I am. Actually, because I care about you guys, I want you to practice this. What's that? Okay. Question. Hold on, Ethan.
Yeah.
Thanks.
Is there any homework tonight?
Yes, number 4.
Oh, okay.